Okay, so this is a little review over Chapter 9, Unions, Intersections, that gives students a lot of trouble. So I want to clarify with this using this example. So this is really solve. So I don't know if it'll let me use the annotate. I want to use the annotate. So I want to use blue. Hopefully it'll let me, yes, because now you can see my pen. Okay, this is a compound inequality. Inequality means not equal exactly, or it could be greater than or equal or less than or equal. So first thing you do if you're doing these, the first thing you do is you isolate your variables, yes? So you know this already. And as you do, you got to follow some rules. On this first one on the left, you are, in order to isolate this, you're dividing by negative. And if that negative is down here, so be careful if you divide by negative or multiply, but that doesn't matter. You have to flip the symbol. This could happen. I'm not saying this will happen on the test, but this could happen. This isn't the part that students struggle with as much. I mean, that's little mistakes, but so what do you get then? You get an x on the left because -2 divided by -2 is 1, so you have 1x, and then you flip that symbol from less than to greater than. Negative divided by negative is positive, and that happens to be a 3. Yes? Mm-hmm. Okay, and then on the other one, you are getting rid of the 5. You are not dividing by negative, so nothing's going to happen to your symbol. You're simply adding 5, so x is less than 8 plus 5. Yes? X is less than 13. Now you have to graph this stuff. So what I usually do in the classroom is I say, okay, let's graph this, but we're putting them on the same graph, and then we're going to talk about what that means, and then we look at keywords. So here's my 0. Here's a 3. You don't have to go 1, 2, 3 and go on forever and get crazy. You just find those items and you put them somewhere in your graph to where you can still see what's going on. Now you look and say x is greater than 3. How would you graph that? And remember, interval notation, and the way we're graphing this, we don't do open circle, closed circle like some people have learned. That's a different book. In this book, we use parentheses if greater than or less than, use brackets if greater than or equal, less than or equal. Okay, and they always face in the direction of the truth. So parentheses, so this is greater than 3, so parentheses. And then everything here needs to be shaded right now, for now, because if x is 100, it causes a true statement, you see? So 100 is somewhere over here, x is greater than 3, 100 is greater than 3 true, yes? So that's for the shading. Anything that causes a true statement in the original needs to be shaded. And this isn't for final answer, this is just right now. And then x is less than 13, so I want to graph that one. Less than 13. So x has to be over here on the left, yes? So if x is 0, it causes a true statement. If x is -1,000,000, it causes a true statement. Anything over here causes a true statement in this original x is less than 13. Okay, less than. So we're going to use a bracket here, and we're going to shade it this way. And then this is not my final answer. This is now when we say, okay, now we decide the shading, you know. So this is critical. This is the critical part that people mess up. The key word is and. In this case, it's and. And this right here is the key word, and. So if it says and means intersection. This is where I make that dumb joke. AI go together like artificial intelligence, unless you're a farmer. No. Okay. So, you know, so and means intersection, AI. Intersection always means where do they meet? You know, where do they meet?
I remember the artificial intelligence.
Yeah, you know, I mean,
I remember that part.
Thank you.
That's what I feel like right now, because there's a house full of teenage boys behind me, which one of them just popped in. He's like, what are you doing?
AI.
Like, go away.
We're busy. Anyway, keyword is and, means intersection. Where do they meet? And this is also, or you could just memorize double shading. Do you see what I'm saying? Like if you're on a road, this car drove that way, this car drove that way. Where did they both cover the ground? Double shading, yes? So and means double shading. So this is, where do they meet? This is where the meat is if you had a sandwich, you know, and then I say, there's my bun, you know? Anyway, in this case. So the final answer graph would not have this piece here and that piece there. The final answer graph is just this piece. And then it says solve the compound inequality. Then it says also put your answer in graph form. This would be my answer in graph form, and interval notation. And interval notation, I say simply drop it below the graph. It's super easy if you just follow directions from me, because the book will do it a little different. And you drop right below and say, what do I see? I see a parentheses. Where is it? At 3, comma. I see a 13. What do you see here? Parentheses. Boom. Final answer.
Wow. That's a lot more simpler than the book.
So much easier because a lot of times the book says, put your answer in graph, in interval notation, and then graph. And I'm like, no, if you have a graph, then your interval notation's cake. So anyway,
Wow.
so let's look at this for a second. I want to leave this up, but then I'm going to do a different color, and I'm going to explain what if this was exactly the same problem, but it said or. So I'm going to do this in green. I'm going to put 4. What if it said what if the original were, whoops, said or. That is the thing, that you do your graph kind of just like this, and then you say, what if it said or? So I'm going to go ahead and graph this again, but I didn't want to completely erase it. And you say, okay, I have a 0, I have a 3, and this, nothing changes, you know, as far as this is the same, and here's your 13.
Mm-hmm.
So none of that changes. And then you say, okay, it says or means union. And union means any shading. This is where I make the dumb joke in class about union. He buys a lot of junk, she has a lot of stuff. When they join in the union, they get married. It's everything you see. Calvin, just a minute, please. It's empty. Yeah. Just wait a few more minutes, honey. Sorry. Okay. Any shading, meaning what I say here is, okay, this is his shop and all his junk. And then this is all of this stuff she brought, but they both have a toaster, you know, and they both brought a curling iron. I'm just kidding, you know. So any shading. So then I'll ask you, where is any shading? Any shading in this specific case is everywhere, you see? So your final answer graph is everything. Okay, Calvin, if you turned the TV off, you have to help me. And you have to make it, help these folks here. Say good morning. Well, he wants to color, so this is gonna get ugly here in a second. Okay, we have to finish class first, then you can color, okay? So anyway, it's all of this. And then you say, well, what is that in interval notation? And you say, well, where does it start? Go ahead, Amanda.
It's the negative infinity to infinity.
Perfect. Yes, because it goes on forever and ever.
Mommy.
So that makes this whole thing easier. Now we have some other cases. It depends on which direction the graph goes and what happens, but I want to show a couple more. But this is really it. You know, this is what matters. Calvin, excuse me. What would you like?
Why is that Miss Amanda?
There's Miss Amanda, but not your cousin Amanda. This is another Miss Amanda. She's a student. And then there's Miss Amber. Miss Amber is wearing a red hoodie. See, they're saying hi to you. So it's a struggle, you know. You don't always want to tell the kid, you know, hush up and go watch TV, you know. So that's why I do my work a lot in the middle of the night.
Yeah. That's why you never sleep, huh?
Well, I do sometimes.
Hopefully he still takes naps and you guys can have a nap when you wake up.
Well, we used to take a nap, and then nap became more of a struggle.
When it becomes a struggle, it's not worth it anymore.
It was more work to put him down.
Yeah, it would spend like 3 hours and they would take like a 30-minute nap. I'm like,
Yeah.
oh, that's not worth it.
It's just, he's almost 4. He'll be 4 in August, so I've decided to just call it good. Calvin, please let
And then
me
they go down easier at night. That's
What was that noise?
I'm not sure.
Maybe it was
Okay, so this is another one. Let's see how this one looks. So x plus 4 is less than 0. So we're not going to worry about what this says. But so x is less than -4. You see, because you subtract 4 from both sides. You're not flipping anything because you're just isolating the x. And then it says or.
You only flip when you're dividing by a negative.
That's right. So I always say if. So some people, you know, that 6x is greater than -18, they want to flip the symbol. I'm like, you're dividing by a 6. You're dividing by 6. If the thing in the denominator is not negative, you don't flip anything. You are simply dividing a negative number this time. That doesn't change the symbol. So yes, so x is greater than, so divide by 6, divide by 6. -18 divided by 6 is -3. Yes? And then I never look ahead and try to plan ahead. You have to wait, Calvin. Have to wait your turn. It's not your turn right now. So let's look at what this looks like on a graph. Whoops. It's a good thing I have a back button. Okay, so this is my ugly graph. Okay, put a 0. And here's a -4. And then the -3 would be somewhere here. So I have some folks that struggle with the number line. If you struggle with the basic number line, you need to fix that, you know. But the -4 is further to the left. So less than -4 means this way. And some people are graphing the wrong direction too. And greater than -3 is this way. Do we agree? Whoops. I'm having issues. So this would be my graph for now, right? And then it's, but then you say, well, okay, what's my keyword? Keyword is or.
Why are you doing this a lot?
It's called work, honey. Okay. If you wanted to finish your movie, turn your TV back on. And then when you get done with your movie, you can play with my pens and color, I promise.
I need to wait for you.
Okay, you can sit right here and wait. Okay, so since it says or, what would be my answer? Any shading, where do you see shading? So some people say -infinity to +infinity. I'm like, but if you had a -3.5, it would not cause a true statement because it's not shaded.
You have -infinity to -4, and then your union.
Very good.
And -3 to +infinity.
Right? So this is where you're coloring any shading, and this is it in interval notation because you go from -infinity to -4, and then you see shading from -3 to infinity. But you have a hole. So if there's a hole, you need to put in a union. Yes? Symbol. Now, some people want to always put a union in. This is where I need to clarify this and do a couple more, just a couple of examples. So I'm going to do just a couple of examples of some without first isolating the X and all that. I'm going to go ahead and isolate it. So I'm going to say, okay, what if X is less than 2 or X is greater than -3, okay? So here's your 0, here's a -3, greater than -3, less than 2, see? Does this need a union? It says or means any shading. There is no hole. So you simply say, where do I see shading? Oh, I see shading all the way from -infinity all the way to +infinity. There's no gap. If there's not a hole, you don't have to put a union in. Okay, so you only put a union in, and union is that union symbol, and that does not go with and. And symbol is really this one. This is the intersection. The and is, this is the intersection symbol, this is the union symbol. So let me look at another one. What if you have something where X is less than 7? Oh, I wanted to, can I go back very far? Hang on a minute. I do, when I have something like this, I do want to go ahead and what if it said and? You know, just so that you know what that means. What if it said and? If it said and, you would say, where's my double shading? And your final answer in interval notation would be -3 to 2. You see it? If it said and, double shading. You know, more examples really help. So and would be this one. You don't want green, you only like blue. I know, baby. We will hook you up with blue on the next one. Okay, what was I doing? X is less than 7? No, 2? I don't remember.
7. It was X is less than 7.
So let's do an and. X is less than or equal to 5, okay? So let's look at this one. It's an and, so first of all, I have my 0, I have a 5, I have a 7, less than 7. So the arrow goes to the left. And then it says less than or equal to 5. So this arrow, and remember, I didn't do very many of them or any of them yet with the less than or equal, but I wanted one for variety, you know, but here's your bracket and less than or equal. So this goes to the left too, doesn't it? Mm-hmm. So you graph it like this first, and then you say and means intersection. Intersection means double shading. So what is your interval notation? And Amber hasn't had this lesson in class, you know, Amanda has had it in class, so I think it's easier for Amanda. But what do you think? Like it says and, so you look for the double shading. So you have shading and shading. So do you see how the double shading, and you would say, where does it start? And is it a bracket or parentheses? Oh, it's a bracket. And it starts at the 5 because that's where your meat is, you know, the double shading. It's funny looking burger. This time it's endless. Then you have negative, goes to -infinity, you see?
Yeah.
And then we'll do exactly the same one with or, and I think we're clear enough. I do believe, like I'm trying to show enough examples. So what if or? So what if or? Same exact thing, so our graph. Hang on, Calvin, we're almost done. these ladies are here, they are committed, and we are committed too, because we want to be successful in this class. And someday you go to college, I hope, but who knows?
Right.
He may not want to, and that's okay too.
Yeah.
As long as he works, work, right?
Yeah.
Okay, so
Seems
what
all
if
I
it's,
do these days.
or, work is all that matters to me. Like, I don't care what kind of job you do, as long as you're motivated. Okay, so what if it's an or? So then you say any shading. And see, where do you see any shading? And you say, okay, I see shading here, double, but I also see shading here. So this is where does it start? At a 7. Where does it go? All the way to negative infinity. Do you need a union? Absolutely not. You don't need a union. There's no gap, right?
Right.
So I think this clears them all up. How are we doing? Was that helpful? So I'll do them again on the review, but shorter. Go ahead. Amanda?
These made more sense, but it was the
Okay.
graphing with the color on one side that I seemed to struggle with more than the and or on the chapter 9 quiz.
Okay, so but they show you a graph that's already made, and then you need to pick the right one, you see? So this is where on, this graph would just look like this. In my math lab, the graph would look like this, where it's a 7 and that's it. And then you see them marked here, you see? And then for the, and in this case, the graph you see in my math lab, they don't show you the part that isn't true. This is just me beginning, showing it. In my math lab, it'll look like this.
I'm talking about the XY axis, not this graph.
Oh, you said chapter 9.
Where you...
Oh, you're talking about the inequality at the end of chapter 9. We had an inequality at the end of
I had
chapter.
a question about when to fill in and when not to fill, because I was looking at my
yes.
exam and I got one wrong because I filled in when I shouldn't have.
Yeah,
So
because I was filling like the wrong side, and I thought I had it in class, and then I went to do it. It was like, yeah, that's where I really struggled. The and or not so much because it made sense.
Oops.
Yeah, that was where I struggled with.
That's okay though. We have one of those. This is something that a lot of students struggle with, though, the and the or, and how to graph it, when to do what, and when to put a union in and all that. So this is okay. That never hurts to do it. Graph inequality. Let's do this one. This is the last one, Calvin, okay? So after this, everything's crystal clear. You can go get you some stuffed animals. You have your stretchy pants on? Okay. Inequality. So this time it has an, excuse me, XY chart. So how do you guys want to graph this? XY chart or y equals mx plus b? So the first thing you do is graph as if it were a regular line. Meaning I want to know where the points on the line are. And then let's act like it was just in less than. Let's act like it didn't have the or equal, so that we can, I want to clarify, like you might have to do a dotted line. But, uh-oh, Amanda left us. This is using slope-intercept form. So m is -4, and this is my y-intercept. Amber, I don't know if you were used to this thing. This is y equals mx plus b form, or if you were used to XY chart. You see, so we're going to do a lot of this week. I'm planning on. I'm not planning on doing much chapter 10 and 11 because it's so fresh.
Mommy.
So when x is 0, 4 times 0 is 0, y is -6.
It's not that thing for the x. It's not deep.
That's fine. When x is 1, then 4 times 1 plus y is -6. 4 plus y is negative 6, and y is subtract 4, negative 10.
Mhm.
So this is me doing plotting points. Is that okay for you, Amber? Because I don't know how.
Yeah, that's how I did it.
So 0, negative 6 is here. And then we have a 1, negative 10, which is off my graph. You know, it's not conveniently located. Let me put a negative 1 in. So 4 times, but for me to find those points, I need to not have this be a less than. I need this to be exactly equals. If x is negative 1.
Mommy, please help me my tool.
After this one. Plus 4, plus 4. So y is negative 2. So this is just me finding points. Negative 1, negative 2. And then this goes in line with my 1, negative 10. You know, if you think about it, it would go down here somewhere, you know, off my graph a little bit. Doesn't matter. And then before you graph it, you know, step 1 is graph as if it's a regular line, or find the points. You know, find the points is really what I'm talking about. And then step 2, is it dotted or solid? You know? So then you look at your problem and say, oh, in this case, I have a less than, so it's dotted. So this or that is dotted.
Mom, you're doing too much.
And this or that is solid.
Mom, you're doing too
Calvin,
much.
bitte. I'm working right now. You're gonna quit whining.
You're doing too much work.
Doing too much work. I'm almost done. I graded all night so that I could spend time with you after this. You are fine. Okay, so here's my line. Yes? You gotta teach kids patience, and you need to do it early. Because if you don't do it early, they're gonna be, my grandson, sorry, I shouldn't say that, but you know, he immediate, it's always, what's next, what's next, what's next, what's next? And it's like, this is it right now. Deal with it. I'm so horrible. Okay, I had to make some room. So are we good with this? Finding those little spot points. And then this is where your question is, Amanda. You know, where do you shade, right? So we're gonna say, this is where we use the famous, hey, this is even funnier now, because I said, we're gonna do a test point 0, 0, looks like toilet paper, and this is the semester of the missing toilet paper.
Yeah, the missing toilet paper. Oh my gosh.
You know, it kind of is. So anyway,
Yeah.
so what is the test point all about? If my line does not go through, you cannot use 0, 0. If you cannot use 0, 0 if your line goes through 0, 0. But if a line doesn't go through the origin, then use 0, 0 to check, because it's the easiest thing to put into the original. So plug 0, 0 into the original. And then you ask, is it true or is it false? So let's plug it into the original. 4x, x is 0, plus y is 0, less than negative 6, question mark. This is what we want to know. 4 times 0 is 0, plus 0 is 0. Is 0 less than negative 6? Too many zeros?
Yeah.
So 0 less than negative 6? False.
No.
If it's false, don't shade where the 0, 0 is. You see? Shade on the other side. Well, almost done, honey. So this time, this point here caused a false statement, meaning this point here does not cause a true statement in the original. So therefore, you cannot shade here. You need to shade over there.
Shade over here.
And you can use anything for a test point. What if you'd said, hey, I'm on a test point. Let me do one. test point, and I'm going to pick something from over here, you know, negative 10, 1. And I'm going to see in the original, 4 times negative 10 plus 1 less than negative 6, question mark. Negative 40 plus 1 less than negative 6, question mark. Negative 39 less than negative 6, true. You see? Therefore, if it's true, you shade on the side that's true. And guess what? That's the same side because we did it right in the first place. Yes? Did that help?
Yes.
Okay,
Yes.
good. Very good. So hopefully that's good. And then we'll do it again, hopefully tomorrow after. Yeah, I'll answer any last minute questions on exam 3, but most people have already taken it. So kind of ready to move on.
I'm going to send you an email about my exam 1 that I've been going over. I had some questions on some that I got wrong, so I'm going to shoot you an email after this.
Okay, I think I emailed you back.
Yeah, well, that was from exam 3. Yeah, the very first exam before we did the online. I totally, got a terrible score on that. So I was kind of going back and figuring out what I did wrong, but I had some questions and I couldn't figure a couple things out. So I was going to email you.
Sounds good. And we can always hook up a little early with the, we can always meet like privately right before people pop in tomorrow or something. Okay?
Sounds good. Enjoy your mommy son time.
Yes, you too. Thank
Ciao,
you.
Calvin.
Say bye. She said bye.
All right.
Bye. Say bye. Thank you. Have a good day.
Now is it my turn?
Now it's your
See ya.
turn.
See you
Bye.
tomorrow.